All right, we're back to another Advent of Code. So this year is a little bit different because we only have 12 days. I'm not sure how long I'll be able to keep up the videos for. I'll try and do them all because I quite enjoy it. So let's get started. For this year, I'm going to use any language I feel like at whatever. Yeah, I'm not going to confine myself to one language. Maybe I'll do some new ones. Maybe I'll do some days completely in Bash, some random stuff. I think as a warm-up, I'm just going to do JavaScript to start with. So, let's see. Well, that was great. Okay, so the elves have good news and bad news. The good news is that they've discovered project management. This has given them tools to prevent their usual Christmas emergencies. They know that they need to get the decorations finished. Okay, so some backstory, as you guys know how it is. This year is a little bit different. We only have 12 days as opposed to the regular 24. Okay, is where it starts. You arrive at the secret entrance to the North Pole base. The North Pole base, ready to start decorating. Unfortunately, the password seems to have changed, so you can't get in. Due to security protocols, the password is locked in the safe below. Please see the attached documents for the combination. Then the safe has a dial with only an arrow on it. Around the dial are numbers 0 through 99 in order. As you turn the dial, it makes a small click noise as it reaches each number. The attached document, your puzzle input, contains a sequence of rotations, one per line, which tells you how to open the safe. A rotation starts with L or R, which indicates whether the rotation should be left towards lower numbers or right towards high numbers. And rotation has a distance value. Okay. So if dial pointing 11, a rotation of R8 would put the dial at 19. Okay, this makes sense. And now I'm guessing it wraps around because the dial is a circle. Yeah. Okay, so we wrap around basically. So if the dial pointing at 5, a rotation of L10 would cause it to point at 95. After that, a rotation of R5 could cause it to point at 0. Yeah. The dial starts at 50. You could follow the instructions, but your recent required official North Pole secret entrance security training seminar taught you that the safe is actually a decoy. Is there a ONPSCS? No, never mind. I thought it was like a weird acronym. The actual password is the number of times the dial is left pointing at 0 after any rotation. Okay, that looks fine. Paste that in there. Let's go back here. We're actually gonna write some bun because what you can do. Well, you just have nice types, I guess. Bun.file of the input. Okay, that's not an awaited thing. Let's go content equals file.text. Let's go processed content. So, wait, what the hell? Where's the input that text? Oh, it's hidden because it's yeah, right. I forget. I'm in my repo, so we can actually just split straight away. It's gonna be an ugly. Oh, it's gonna be a nice thing. So we split on there. Let's console log the process. I love doing the watch, thing. Run ts because I can just, you can just do this. Oh. Okay, that doesn't look good. Oh, I had to save. I think it opened. Oh, that was weird. Okay. So we have this. There's the parsed content. Let's oh, we have the very last. I forget. So if I trim, I think we get rid of that. Yeah, trim the whole thing at the beginning. Then we map for L, where actually we're gonna return just a number, a positive number. So this is gonna be a little bit ugly actually. So it's gonna be it's gonna be the number of L is equal to left, then -1, otherwise 1, and we're going to times that by the number of L.slice1. Line 0. Alright, nice. So we trim and then we split. We take the first character, which would have been if I comment this out, you'll be able to see this. Again, you know, we have an L, so we check if it's L, we do -1 because it's going to go to the left, right? So we want to take away straight away. You'll see why I do that. It's fine. I'm going to do the rest in a for loop because it's a bit easier to follow, I think. Part 1 is 0, let position equals 50. Let's console log part 1, keep that under there. So for const step turn, let's go turn of processed content. Actually, this is actually turned, isn't it? Technically. And we go position. Oh, I need to remind myself something. So if I have -20, say modulus 100, what is it? -20. Yeah, okay. Basically, we're gonna need to do a wraparound. I don't know if there's a nice way to do that, or other than just like a simple if statement. Let's go position plus or equal turn. Okay, plus or equal turn, and we go if position bigger than 99. Position is equal, so if it's 100 equals 0, 101 equals 1, so actually we go position minus 100, and then position less, we can delete that, less than 0, we go position equals 100 plus position, because it's a negative number, so it's actually going to subtract, so if it's -1, that should actually go to 99, so 100 plus -1 is correct. And then I think after all those adjustments, if position is equal to 0, part 1 plus plus. Okay. That works. Let's 416. Is that going to be right? No. So we gotta write this, so there's a difference. Okay, so the numbers can go beyond the normal. So actually this could kind of go out of bounds in a way. In that case, difference between 200 and 100, like, you know, 202 is the same as 102, which is the same as 2. Right, it's like, because each 100 is a full turn anyways. So we can just do, maybe make a better one here. Let's do const effective turn, I don't know what to call that. But we modulus 100. We do effective turn 964. Okay, great. Let's actually, I want to label this part 1. Nice. Okay, nice. That was easy. Part 2. You're sure that you are sure that's the right password, but the door won't open. You knock, but nobody answers. You build a snowman while you think. As you're rolling the snowballs for your snowman, you find another security document. Okay, different password method. You remember from the training seminar that this method means you're actually supposed to count the number of times. Okay, so yeah, it's kind of what I thought part 2 would be. Of times any click causes the dial to point at 0. So every time we go through it, I guess, not just where we end up. Okay, so we go 50, rotated 82, passes 0. Okay. Example points 3 times and just plus 3 times during a location. So okay. Okay, so we have part 2. And part 2 we're going to check along the way, but actually now 202 is not the same, because remember if we do like, if we're at 1 we turn it to 100. My algorithm right now would say the effective turn is 0, but we did go around 0 once, so maybe I need to know the full turns. Actually, let's strawman this first of all. Let's not touch that part first. Let's do the other parts. So, if it's bigger than 99, that means we've gone around at some point. We do part 2 plus round up here. Start like this. See what we get. Does it work for the input? Does not. And it doesn't work for the input. Let's do some debugging. Well, actually, LCF position is 0, part 2 plus. We don't want to go into the cases twice. Okay, that reduces 1. Because we only want to hit one case. But let's console it. Let's have a look. Because it's I feel like I think a lot better when I have something like this. Let's do an afterwards of the position, and let's do a nice double line separator. So, because we start at 50, we go below, and let's actually step the turn. Okay, we go below, we count 1, the step is minus 68, we start at 50, we pass 0, perfect. We minus 30, we go 52, we don't do anything. We don't like add 52. And then 48 plus, we go 2, 0. It's probably where the edge case is. We go 2, 0 to the right, stay at 0. And then we add on the left on a minus 5. But actually, it only added that because we are technically at 0 at the very beginning, but we didn't pass 0. We didn't pass 0. We just went to the left again. Ooh, okay. Let's think. So, basically we want to discount when if we start at 0, you know? If we start at 0, we might want to discount some of these turns. So, if the position is 0, then might take away part of part 2. Start at 0. Well, because this is a strawman, sorry. I'm gonna start writing. If position, actually, I'm gonna keep a record of the previous position. And keep that there, and we're gonna start by just going position for turn. It's not equal to 0, and I actually think this will work for this example input. But I have one other thing in mind. Okay, yeah, so it worked for this input, but I have one other thing in mind that might make this kind of weird. Yeah, okay. So it works for this. But, I mean, I don't like this if statement, full stop, to be honest. Because it's like we're counting a couple of things twice. And if we start at 0, is there a better way to represent that in state rather than like the way we have this instead? It's like maybe not. Maybe not. But okay. Let's say we start at 50. We go left 50. We go right 100. Okay. Let's think about what would happen here. So if you start at 50, you go left 50, you're at 0. You hit 0 once. You go right 100. You hit 0 again. So that should be twice. Part 2 says only once, because we did start at 0. But now, because this is 100, the effective term was 0, so nothing happens. So actually, we want to keep something else in mind, which is a turns, or like full turns, which is math.floor of, is there a div? No, there is. A math.floor of the, God, what is it? The turn over 100. Okay, so if in full turns, turn -1. Math.absolute. Okay. Turn 1. Yeah, okay, so turn 0 for that first number and then turn 1 for that second one. Okay. Now, what we're going to do is we're actually going to do part 2 plus or equal to the number of full turns plus 1 there. And now we can no longer actually use this statement. Before turn is equal to 0. Then this is 0, otherwise 1. And then we don't need this. We always add. Okay, that's 2 on my example. That's 6 on here. Does this make sense? Can we think of another example? Okay. So let's go left 50, right 100, that's 2. We're at 0. Let's go right 500. 0, 1. Okay, what should we see here? Ooh, that's not what we should see, I think. Because we'll go 50 to 0. That's 1. And then back to 0. And then 1, 2, 3, 4, 5. So 7 we should see. Yeah, and we're not. Because, okay, wait. The full, wait. Turn. How's turn 1? Full thing. 500. This says turn 1? No. Why is it turn 1? This. Oh, this is precedence issue. That was precedence issue. Okay. 7. Are we gonna... Have we discounted all edge cases there? Potentially. Potentially we discounted all edge cases. No, we have not discounted all edge cases. Too low. So we're not counting some. That is interesting. We're not counting some of them. Where could we not count some of them? When we start at 0 and we go to 0, we've counted that. If we go to 2 and then we end up at 0, we've counted that, and we've discounted when we do start at 0. Then we add 1 on top of that. Full turns. It doesn't really matter that we use this for the effective terms and then check position at all. That's fine. It's completely fine. Full turns, so we're missing something here. We're missing some edge case. What is that edge case? Okay, let's have a quick look at the logs, I guess. From the stuff we have. These don't look too interesting then. Full thing 13, turn 1, 13 to 47. And I don't like that. I don't like these logs anymore. Actually, I don't like this log here. Position after. Let's do before equals. Before equals position before turn. After equals position. That's the turn up there. Turn equals turns. Let's go. Full turns. Okay. Now let's do something. Let's go L24. Let's go L80. Let's go right 230. What do we get? We get 1. Is that right? So I don't think that's is that right? Start at 50, and then we go to 26, and we go right to 80. So we go to 106, which is just 6. So at this point, 10 is there, and we go to turn a few times, which we don't count. Yeah, look at this. So we go below 0, which makes sense. The turn is -80. It's the second line. And then the second one, we turn 230. The turns are 3, before and after. Wait, so before 26, after 46. 26 after 46 of. Start at 50, 26. What's after? The current position. Turn is -80. Hold on. Sorry again. Sorry. 26 and then left -80. So that is 26. So I'm struggling to do maths because we don't go right. Actually messed up there. So it's actually going to be. Well, I guess 46. 46, 454, 54 plus 26. Yeah, okay, yeah, makes sense. So we did pass 0 there, though. And then on 46, we turn right 230 times to go to 76. But actually, we go to 146, which is 0, and technically, 46. And then we go 2, 4, 6, where we pass 0 again, and we go to 2, 7, 6, which is normal. We don't pass 0 again, which is actually, this is like a going step, it's 36, should be. It does say after 36, but we pass it 3 times, and we're only counting. I'm gonna put this example here. We're only counting once, and we're only counting once at the top, we're not counting once after, because we're doing the effect, it's because of the effective turn. I see, actually. So, if the effective turns, plus here, plus there, before turn, so maybe we always, I know. I have an idea. So if we always add 1 when these here are true, and then after we go, if we go part 2 plus or equal to the full, is it full turns now though, because maybe we don't need to add 1. If position before turn is 0. This is very interesting actually, because we kind of do want to add this, but we don't always want to add this one. So maybe let's do like bound to add, which is going to be this entire thing, and we get rid of that, and we go here bound to add. That's 3. Because now we only add 1 on when we adjust the position if we didn't already start at 0. Because if we start at 0, what will happen is you're going to, maybe only some of the time. Only if you go down. If you go up, that's fine. Only if you go down, yeah, because if you go up, that's fine. Ooh, I think I've just thought of another like edge case. I think I like that. So if we go left 50 and then right 50, what happens here? Should only be 1. Okay, it is 1. Maybe it's okay then. I think I have some idea that this might not work in a specific case. Let's get this again. Okay, it's 6. There is one case that I'm thinking of that might not work, because if you start at 0, you go to the right, you haven't passed 0. Let's try it first. That's a higher number. Okay, never mind. I was kind of making up a scenario in my head. Okay, that was fun actually. It's kind of like, you didn't need any like particular knowledge there, but it definitely isn't as straightforward as possible. And it's a very, very good example as why like debugging with care is so important. So I took my time to come up with example inputs, sketch them out a little bit, see that my program handled them. Now let me try and explain myself a little bit. And I'm really, really curious to see what other people have done, because I think there are definitely good ways, especially like this. I think this branching selection is not needed at all. I think there is a way to represent the state that this is not needed. Also, have I done something really stupid and not know how to do a ring buffer? I don't know. I'm not sure I have, because maybe I have. I think maybe I did something stupid here with adjusting the position. Not doing a ring buffer. Again, I really, really want to see what other people have come up with. But let's have a look at our full solution. Yeah, and basically the magic sauce is this line here. You always add the full turns to the part 2, because most of the time this will be 0, right? Because there's no full turns. You see here on the debug lines, because most numbers are below 100. So this is always going to be 0. But you always add it. You always add it, so if I want to take a little bit of time to just polish this ever so slightly. And okay, so so the answer is 5872. That was the right answer, right? 5872, and I wonder if I add it here, this will not work. Like if I get rid of that, yeah, no, because we need to keep it in there. Bound to add position. This. This is probably like a switch case kind of thing. Oh, but you have to break. Actually, I think this is probably fine. The bound to add, I can probably move just above the if statement there. Position before turn is not needed, is it? Well, I can get rid of that by just doing position here. The effective turn. Yeah, no, this is good. And doing this here, leaving that there. Alright, perfect. It's a somewhat clean solution now. Okay, thank you so much for watching, guys. I'll be back tomorrow with another one. Take care.